Hello friends, this is Dr. Antonio coaching data analysis using R2. In this video, I'm going to show you how you can use weighted sum model so as to improve the way you make decision. In this video, you will learn step by step how you can make a choice when you have many alternatives and you have many criteria. When you want to use this model, the first thing you must have is to have the decision matrix, which has all alternatives and the value for each criteria. For instance, when you look at this matrix, suppose that you have made assessment and for each car you have given all these values. For instance, for car 1, the quality you give this point, condition you give this point, the delivery days you give this point, and the security you give this point, and the fuel consumption you give this point, and the price is this one. Make the assessment for all your cars. What you cannot do is to make the summation of all these criteria values. You cannot add these values because these values do not have same measure. And to use the weighted sum models, all values must have same measure. And if it is not the case, you have to make what we call normalization. You have to normalize our decision matrix. And the way we do normalization depends on whether the criteria is beneficial attributes or non-beneficial attributes. What you need also is the weight of each criteria. Because when you want to calculate the score, you will multiply the weights for each criteria to the value of each criteria, and the summation will give you the score of each alternative. Now let me show you directly how it works. Suppose this is our decision matrix. Suppose that we are going to select a car among 10 cars. It may be 10 or more than 10. It may be 10 cars or more than 10 cars, and you may have these criteria, or you can have less or more than this criteria. Now you have here we have 6 criteria, but you can add other criteria. When you understand the way it works, you will be able to use in your own case this model. Suppose these are decision matrix, this one, and after discussing, you have given weights to each criteria according to the importance of each criteria in your final decision of buying or not. Suppose that this quality has this weight, condition this weight, delivery days this weight, security this weight, fuel consumption this weight, and price this weight. That means, as you can see here, the most influential criteria is price, as the price really has a high influence in your decision of buying or not. Now the second step is to differentiate beneficial attributes and non-beneficial attributes. For beneficial attributes, the higher value is preferred, and for non-beneficial criteria, the minimum value is preferred. For instance, the cost is non-beneficial criteria, and when the cost is low, the better it is. But for the quality is beneficial criteria. Better the quality, better it is. The way we are going to make normalization depends on whether the criteria is beneficial or non-beneficial. For beneficial criteria, we will consider each value divided by the maximum value, but for non-beneficial criteria, we will consider the minimum value divided by each value. Now the next step is to determine or to identify maximum value for beneficial and minimum value for non-beneficial criteria. The next step is to identify the maximum value for beneficial and the minimum value for non-beneficial attributes. Now we use a function in Excel which allows us to identify automatically the maximum value or minimum value. This is a function of Excel. Now I'm going to select here and I press enter, and I can drag this formula. I drag this formula for beneficial criteria, these beneficial criteria attributes, And now here, for non-beneficial criteria, the minimum is the best. We need, or is the minimum is desired, and we need to find the minimum value. Minimum, I select here. Press enter. Minimum, and I can type this formula. Now I have a maximum and a minimum which will help me to make normalization of our matrix, because the data I do not have same new. Now the next step is to calculate the normalization of our matrix. And for beneficial, I said that we need to divide each value by this one, divided by the maximum value, this one. Now I can just do this so as to drag the formula. Now I can drag this formula like this. Now as you can see here, this was C, sorry, this was C here. Now when I drag the formula, it changes. Okay, that's good. And now I can drag down the formula like this, so as to drag the formula. That is the normalization of our matrix. Normalization of our matrix for beneficial criteria. But for non-beneficial criteria, I will take the minimum value and divide it by each value. Now I consider this one, which I will fix, and I take this one. So I divide by this one. This one I divide by each value here. I can press enter and I can drag the formula here. This is normalization. I'm making normalization. And now I can drag here the formula like this, and I can also drag the formula down like this. Okay, now we have normalized matrix, and the formula I used is this one. Let's show you the formula for normalization. This is the formula for normalization. Sorry, this is the formula I used. For beneficial, I consider each value divided by the maximum value, and for non-beneficial attribute, I consider the minimum value divided by each value. This is how I did the formula I used to make normalization. This is what we call normalized matrix. The next step is to calculate the score for each alternative, each car. To get this score, we take this value multiplied by this weight plus this value plus multiplied by this weight, and so on for each and so on for each car. Now we do this equal to this one multiplied by the weight. Now I can just fix here, so I'll drag the formula, plus this one multiplied by this one, which will remain fixed, plus this one multiplied by this weight, plus this one multiplied by this, and plus this one multiplied by this, plus this one multiplied by this. But this will not change. I can fix this because it will not change. The weight will not change. The weight will not change. I can fix the weight because the weight will not change. Now I'm just fixing. I fix it because it will not remove or change. This is, yeah. Let's fix it. You can use F4. And this also must be steady, do not change. And this one will not change. Okay, now that is the weight or the score for the first car. Now I press enter. Now I can drag the formula here. I can drag the formula. I have to wait a moment. Okay, now I can drag the formula so as to calculate the score for all cars. Okay, now I drag the formula here. Now, okay, I finished to calculate the score. The next step is to make ranking, to give a rank to our equation rank, this one, of this value, but in this matrix. So as also I have to fix this matrix. Sorry, there is a matrix error, error, because it may be I didn't calculate for 10, but no problem, I will do. Okay, I press enter. Now let's check for 10. I didn't drag until when I calculated this one, this normalized matrix, I forget to reach this level. But no problem, I will drag the formula here. Sorry, I have to drag the formula until here, the same. The same formula. The same formula. Just to drag the formula, because when I dragged, I forget to reach on 10. Now I drag the formula here. Okay, now it's okay. Now I will see the final results because now I finished to do. Now you see the advantage of this model is to include in your choice criteria which are not quantitative, which are ordinal or qualitative. Now I can drag the formula, and you see now this car is the best because it has the highest score. This one, 5 car. This one is the best car because it has the highest score. Even look where I just need to the highest score. You selected this, and I come here and I choose the highest score here. I use this one. I select, but I need one value. Need the highest value. I need one, which is the highest. Okay, this one. It's okay. It's okay. This one. I will do here. I choose the minimum value. Here I choose the minimum value. This one I will choose the one which is the minimum value here, because this is the first one. Okay. Now based on this model, you can see now we can select the car 5, number 5, which is the best car we can propose. Now friends, you can see with this model we can include many criteria which cannot be considered when you don't use model. We are selecting supplier, for instance, or when you are hiring. Is the main difficulty is to include the criteria which are not quantitative in your choice. Okay, friends, this is the end of our presentation. I think this will help you to improve the way you make a decision. And this model is simple and gives you better result when you are making your decision. And thank you for watching this video. For next video, bye.